Alright, so let's deal with the example of linear applications today. So this is the one that's number 9 on your handy dandy review sheet. So Birdie's Gourmet Pretzel Shop specializes in selling the finest chocolate covered pretzels. Becky bought 4 white chocolate pretzels and 6 dark chocolate pretzels for $10.50. Holden bought 8 white chocolate pretzels and 3 dark chocolate ones for $9.75. So we've got to try to figure out, okay, well, what are the variables here? What's unknown? Well, I don't know the price of either one of those as I look at it. I know what the combined price is, and I know the amount of the different types of pretzels that we got. So what would be important to know based on the system if I wanted to buy some of my own chocolate-covered pretzels and I have a limited amount of money? So, well, I need to know the price of each one. So as we scroll down a little further, let's define our variables. Now, looking at it, we've got white chocolate, dark chocolate. Does it really matter what variables what you use? Doesn't matter what letters, but I like to keep it simple and sweet. That way I don't lose track of, all right, well, what's X, what's Y? So we're going to let W equal the cost of the white chocolate pretzel. Then we're going to let D equal the cost of the dark chocolate pretzel. So now I've got my variables defined. Now I got to come up with the equations that represent what goes on here. So I'm going to grab a pen here and underline some things that are important. So we've got Becky. She got 4 of the white chocolate, 6 of the dark chocolate, and her cost was $10.50. So let's take a different color. Let's go with green. Holden. So we got Holden. It's a completely different situation. He got 8 of the white chocolate pretzels and 3 of the dark chocolate for a total of $9.75. So what we have here is we've got 2 different cases, if you will, of somebody buying the different types of pretzels. So we're probably going to have an equation that deals with Holden and what Holden ended up ultimately buying, and then one that deals with Becky and what she ultimately bought. Alright, so let's just roll down a little further and try to get our equations. Again, this is number 9 on your review sheet, so you can follow along that way. So what system of linear equations would represent this situation? Well, as we go through, hold on one second, I want to just slide this way, maybe. Alright, as we slide through here, here's our first situation with Becky. So we've got 4 white chocolate pretzels. Then we've got 6 of the dark chocolate pretzels for $10.50. We got 8 of the white, 3 of the dark for $9.75. I've got to figure out a way at which to get rid of one of these variables, which would be elimination, or I could go through and set each equation equal to a singular variable. That would be a pain. So what I'm thinking is the best option might be, and this is one of the questions that they're going to ask you, what method did you use to solve? I think it would be best to use the elimination method. So if I do that, the top equation is not going to change. I'm going to try to drop out the D's. Now, could I have dropped out the W's and eliminated the W's? Absolutely. You just would have done something slightly different, but nothing huge. So I'm going to leave the top equation alone, just bring it across for the ride, and I'm going to multiply every single thing in the second equation by a -2. So there's my first equation, not touched. Here's my second equation now. Okay, so I just multiplied everybody by a -2. That's all. So now the great thing about this, and why it's called elimination, of course, is that from this I can now eliminate that variable. I'm done with that variable for now. So then I roll down through here and I get, okay, well, that means then this is going to be -12W. This is actually $9 difference. Now in order to get the W by itself, I need to divide by a -12. Well, a negative number divided by another negative number is going to give me positive. And lo and behold, we end up that W is equal to 75, meaning 0.75 or 75 cents. So that means a white chocolate pretzel costs 75 cents. Now, once I get this information, what am I supposed to do with that? Alright, so there's W. Yes, got one thing. What do I need to do? Well, we need to take that and we need to substitute it into any of these. It doesn't really matter which one. If I wanted to, I could substitute it in for the W there, or I could branch off and substitute it into the W there. Doesn't matter. 6 in one hand, half dozen in the other. Okay, so now we come down, scroll through a little bit. I decided to put it in the first one, give myself a little bit less arithmetic to deal with, but the nice thing is it doesn't really matter because you're using a calculator for this. So you're going to have the 4 times, you substitute the 75 cents in, plus 6D is equal to 1050. Well, 4 times 0.75, $3. So 3 plus 6D. Now I got to move this 3 to the other side by subtraction, so I'm going to subtract 3 from both sides of the equation. 6D is equal to 750. That's just a cursor line, so it's not a number or anything else there. So I get 6D is equal to 750. What do I do next? Divide by 6. So now I know the dark chocolate pretzel is $1.25. All right, so let's think. They wanted to know what were the costs of each. Okay, so based on the solution to this system that we just went through and did, each white chocolate pretzel costs 75 cents, and each dark chocolate pretzel costs $1.25. And that's it. Okay, so hopefully this helped a little bit with just, the hardest part is usually going to be just setting up the equations. Once you set up the equations, the rest of it, you pretty much know how to do. So, really make sure you pull out the information way back in the beginning. Pull it out. If you have to, underline things. Get things, underline once. If you don't have colored pencils, underline another one twice, so that way you can see the visual as to what do I need, what is necessary. But remember that you've got to define everything first. Then you've got to go through and actually do the work. So again, we chose elimination in this case because it was just easier to get rid of one of the variables than it would be to solve for a W or get a D equals. It was just easier to do it in this case. All right, so hopefully that helps you out with number 9, and let's roll on to the next one.